Welcome to Lawyer Up with HMC, where we unravel the complexities of legal battles, share insights into high-stakes litigation, and provide strategies for navigating the legal landscape. Join us as we delve into and discuss common legal issues and interview industry professionals and experts in the field. Whether you're a legal professional, a business owner, or simply curious about the world of litigation, our podcast offers valuable knowledge and practical advice to empower you in your legal journey. You can find this show on all the major platforms, including YouTube, LinkedIn, Facebook, Apple Podcasts, Spotify, and on our website, hmclawyers.com. Now here's the host of the Lawyer Up with HMC podcast, Kristen Hagg.
Hey, good morning. Welcome to another episode of Lawyer Up with HMC. I am your host, Kristen Hagg, and today we're going to be talking about a topic I really enjoy and find fascinating, accident reconstruction. And our guest to help us with that discussion is Patrick Ryan of Graham Ryan Consulting. Patrick completed a mechanical engineering degree at McMaster University in 1994 and has been conducting motor vehicle accident investigations ever since. And I feel that your firm website may be a bit out of date as it still refers to the Court of Queen's Bench of Alberta, but it would still probably be accurate to say that he has conducted over 3,000 motor vehicle accident investigations since 1994. So welcome to the show, Patrick.
Thanks for having me.
Yeah, you bet. And I emphasized Patrick because earlier I was saying I've been calling you Pat for years and I wasn't even sure that I had cleared that with you. But as you said, you respond to anything up to hey you. So that's good to know. Exactly. I feel a little bit better about that. So before we get into things, why don't you give the audience a bit more information about your background, education, experience, expertise, all that fun stuff?
Sure. Sorry to correct you, but I graduated from Memorial University, not
Memorial
University. Yeah.
How did I put? Well, I'm double checking that website because
blame my website. That's fine.
I'm sure the website's fine. No, that was my mistake. Sorry about that.
No worries. So yeah, I am a mechanical engineer by training. Completed my degree in a long time ago now, 1994. And that was a cooperative program which interspersed work terms with study terms. And one of my work terms, I should say, I had a placement with Transport Canada in Ottawa with the Road Safety Directorate doing seatbelt investigations. People would complain to road safety about failure of the seatbelt, either during a collision, or this is back in the new days of airbag controls, airbag systems. So there used to be airbag complaints, people misunderstanding what airbags were supposed to do or under what circumstances airbags were supposed to deploy. So we would do these investigations to determine the appropriateness of the airbag deployment, whether seatbelts were in use, and all that kind of stuff. I discovered I had both an interest in and an aptitude for the topic. So shortly after graduation, I started working in the field, and I've been doing so ever since. So I actually have more years of experience doing this job than years have elapsed since graduation. So I guess.
And so is that number, is it even higher now? Over 3,000 motor vehicle accident investigations. Can you even estimate how many you've done by this point in your life?
I think the last time I actually calculated it, my best estimate is I'm at or above 5,000 now.
Wow. Okay. Well, you know your stuff then. And I know from speaking with you.
I like to think so.
Well, at the very least, from talking to you, you sound like you know your stuff. But no, I know from working with you on files, you know your stuff for sure. And we're very lucky to have you here to talk about this stuff. And as per usual on this show, I like starting with the basics so people have a little bit of a background. So can you maybe just sort of explain generally what accident reconstruction is and tell us a bit about what can be done by engineers such as yourself?
Sure. Very generally, accident reconstruction is the field or the study or the science of reconstructing the events of a given incident. We make use of a variety of evidence sources that may include scene evidence or vehicular evidence, and to some extent witness evidence, although you as a lawyer, I'm sure, are acutely aware of the limitations of witness evidence. We like to say that the physical evidence doesn't lie. That may be a bit harsh on witness evidence, but people can be mistaken for any number of reasons. So there are always limitations to what people can perceive, how people's memories work, how accurate people can be in estimating things like distance and time and speed. So there are certainly very significant limitations if we had to deal strictly and only with witnesses. Excuse me. The When done properly and when the circumstances of an event lend themselves to it, it's possible to get a fairly in-depth representation of the circumstances of a collision by analyzing the physical evidence. And by physical, I also mean electronic, because that's more and more very significant data source these days. But in its simplest form, in its most traditional form, one could, for example, examine. Let's take the very simplest example. If we look at a skid mark, we could say a vehicle that generated this skid mark, knowing that it started at a given location and came to a halt at a second location, we can calculate how fast it was going. That's probably the absolute simplest form of evidence one could describe. Beyond that, we can look at, for example, skid marks from two vehicles, post-impact and pre-impact skid marks. And not always skid marks. There are other types of marks that vehicles generate as well. We can look at the crush damage to vehicles to determine their alignment at impact and their relative motion at impact, their motion relative to one another, I mean, and the severity of that contact. We can look at physical components of the vehicle, such as, for example, signal light or headlight filaments, to determine whether those components were illuminated at the time of the collision. We can look inside the vehicle at evidence of contact by occupants or objects within the vehicle. We can look for loading evidence on seatbelts. We can look for contact against airbags. People, things, objects generate evidence when they come into contact with one another. The more enthusiastic the contact, the clearer that evidence tends to be. Maybe a little ghoulish on my part, but I always say I prefer the more severe collisions because we can give more. We can give answers more readily. The evidence is clearer. Here in Alberta, of course, we've been operating under the CAP regime for some time with regard to minor injuries, so we've seen a big reduction in the number of low-speed, low-severity collision investigations that we do. We still do some.
Right.
In some cases, those can be a bit frustrating to me from a professional perspective, because the evidence that's generated can sometimes be so unclear or so limited as to not allow a real precise opinion regarding collision circumstances. So generally, like I say, I like the more severe ones in a sense, because the evidence tends to be clearer cut and allow more authoritative or more conclusive determination of collision circumstances.
Yeah. There's usually, we'll get into this a bit more later. Maybe we should just get to it. Is, both from your perspective, our perspective, in those more significant accidents, because of the level of significance, evidence is gathered and held and kept early on following the collision. Whereas, when people get in these smaller accidents, police aren't involved, and the individuals aren't really thinking, "Oh, I'd better take all these photographs and record all this information and keep all this data available so that it can be used in litigation later on."
Absolutely. We always find that the earlier we can get involved, the more effective we can be. So vehicles still exist, scene evidence still exists. We can document damage, we can download electronic components, we can attend the scene and do measurements and photographs. All of those things may be possible after the fact, and in a lot of cases are possible after the fact. It can just be a little more difficult at times. For example, I've worked on cases where, as you say, police didn't attend, or a local detachment may have attended and taken a couple of photographs, but no measurements were taken and no vehicle downloads were taken. But we have techniques that are available to us to overcome some of those limitations. right now, for example, one technique that I like to use, have been using more frequently, is to do aerial photography of a scene using a UAV drone and generating a 3D model, an accurate 3D model of the collision scene by making use of what are called ground control points and surveying those in using GPS-based survey system. Um, Once we have that 3D model, I can take, for example, two or three photographs that might have a skid mark or vehicle rest positions or whatever in them, and I can paint that evidence back onto the 3D model of the scene and end up with a plan view. Well, look, here's a skid mark, and we can measure, and we can use that as input in our analysis. So it is possible to overcome, to some extent, the limitations of the amount of documentation that's been done post impact. But again, the earlier we can get involved, the easier it is for us to make sure that we're gathering all of the evidence that's related to the incident.
Yeah, and maybe this is just a really obvious question, but if you're going to be going to to trial and trying to make the case of, okay, well, what happened in this case, having visual aids and things like that, that must be really helpful if you can generate something to actually show people what happened rather than just tell them what happened, right?
Absolutely. I think I, as an engineer, and we as technical professionals, tend to fall into the trap of thinking that when we describe something, the audience is appreciating what we're saying. Communication is, of course, a two-way street. I can say something, and if the person I'm speaking to doesn't understand what I'm saying, then communication isn't occurring. I take very seriously my role as a communicator, and if particularly in the context of trial, as an expert witness, I'm supposed to be a friend of the court. I'm supposed to be unbiased. I'm supposed to be there to assist the court in interpreting evidence. So it's critically important, in my opinion, that what I'm saying is being understood. So as part of that, yes, visual aids are critically important. So diagrams, top-down views of collision scenes, photographs of the collision scene, photographs of the damage to the vehicles, animations. We do simulations. We might use computer software to determine the circumstances of a collision based upon skid marks, gouge marks, fluid sprays, rest positions, and simulate the collision to determine from a physics perspective. I'm not talking just generating a cartoon here. I'm talking about with physics underpinning, determine what kind of impact speeds and vehicle dynamics are required to generate the evidence that we see. Once we have that mathematical analysis done, it's I won't say trivially easy, but it's relatively easy to then generate any number of representations of that top-down view of the vehicle behaviors, chase helicopter view, driver perspectives. Those are all readily doable once we've got our underlying simulation of the collision circumstances. And that's assisted when I'm able to do things like go out to the scene and build a 3D model of the scene upon which all of these things can take place. So we end up in a position of being able to do near photorealistic renderings of the collision circumstances that we can show to interested parties, the court, the mediator, whatever the case might happen to be. It also allows you to do things like examine what if, which can be very difficult to do, or to anticipate all of the possibilities at the outset of a given analysis. So someone might put a question to me and say, well, we know that this collision occurred because this vehicle was going this fast and this other vehicle was going that fast. What if the speeds had been different? Well, then we can run those alternative scenarios, those what if scenarios, and again, represent them from perhaps a driver's perspective or a chase helicopter perspective or what have you, to allow the finder of fact or the parties to the incident to appreciate the contribution, the effect of the decisions of the drivers.
Right. And I was actually just going to say, well, at least make the connection for people that are listening that might not, quite understand the implications of that. And I think I've had cases where you've done this for us, where, yeah, if somebody was going, well, the allegation is that they were going too fast, and that led to was a contributor to the accident, you could look at what if they'd been going the speed limit or at a lower speed, might they have been able to avoid the accident, right?
Correct.
Okay.
That's a really common what if scenario we work with, particularly in intersection collisions, whether they're right angle collisions or left turning collisions, for example. And there tend to be two what ifs in each of those scenarios, because you might have the cross direction or the left turning driver seeing the other vehicle, but making the assessment that it's sufficiently far away that they can proceed in safety, when it's the speed of that vehicle that resulted in the subsequent collision occurring. And so we can evaluate it from that perspective of when party A made that decision to proceed across the highway, or when party A made that decision to proceed into the left turn, how far away was party B? And because of the speed of that vehicle, was party A justified in believing that they could complete their maneuver in safety? So there's that what if, but then there's also, you can look at it from the perspective of the other driver and say, well, this driver, as they approached the circumstance, the cross direction traffic, left turn or what have you, realized there was a threat and started to respond. They swerved, they braked, whatever. They were unable to avoid the collision, presumably, otherwise we wouldn't be here. But what if at that moment that they perceived the threat, what if they had been obeying the speed limit? Could they then have avoided the collision? So we can end up in a situation where there's two arguments about who could have avoided, or the degree to which the actions of that driver contributed to the collision. And we can explore those, and we can illustrate those in a number of fashions.
Yeah, no, it is. It is incredibly helpful in those types of cases, because we're kind of asking these what ifs, and then you go and you ask the individual, and of course they're going to say, "Oh yeah, they were going super fast. They were going way too fast, and I for sure thought it was safe to go," and things like that. Like you say, like people's memories and, well, self-serving evidence, all these different issues. It's just very beneficial to have you guys come in and give us an objective view of what happened. So just as like the ways that you guys can present evidence is evolving, you and I had previously talked about just the types of data that you're able to use now is evolving and changing due to technology. Can you tell us a little bit more about that?
Sure. As I previously made reference to, the old school approach, if you will, is let's look at skid marks. Skid marks are getting less and less common. Their vehicles these days tend not to skid. We've got ABS brakes, for example, or traction control that intervene and prevent skidding from occurring. So, in a lot of ways, what we see in terms of road evidence has changed over the past years, decades. And we can no longer, in a lot of cases, rely upon pre-impact skid marks to give us an indicator of what that vehicle is doing. Luckily, technology has, in some ways, given back what it's taken away, and to a further extent, in fact, because in the old days, we might have seen 10 meters of skid marks pre-crash, or 20 meters, or 5 meters, or whatever. And that would give us a very limited insight into what that vehicle was doing immediately prior to collision. But these days, we are very frequently encountering data sources that include a much longer pre-impact time frame, and therefore greater distance, so give us a better understanding of what vehicles are doing and so on. Specifically and generally, airbag control modules. Over 90% of the entire road fleet right now has some form of downloadable data contained in an airbag control module. Mid 90s to high 90s of current model year vehicles are accessible by one specific tool, the Bosch CDR system. And the few vehicles that are not accessible by that tool are accessible in a lot of cases by their own tool. For example, Hyundai and Kia have their own standalone tool that is used to access data contained in the airbag control module. Tesla has their own tool that allows access, of course, but it's a very, very small fraction of the road fleet. By far the most useful in terms of broad applicability is the Bosch CDR system. Generally speaking, we as Canadians are subject to a lot of the same regulations as the American market. And of course, they're a much larger market. We're about 1/10 the size. So we've kind of inherited a lot of their regulatory decisions. One of the things that the American NHTSA, National Highway Traffic Safety Administration, implemented some time ago was a code of federal regulations called 49 CFR Part 563. It doesn't actually say you have to do crash data recording, but what it does do is specify that if you are doing, and it calls it time series data recording, if you are recording data points relative to a time, then the regulation applies. And the long and the short of it is the regulation specifies the types of data elements that have to be present. It specifies the time frame over which those data elements have to be present, and it specifies that those data elements, that data has to be accessible by a commercially available tool within, I believe it's 90 days of the sale of the vehicle or something like that. So basically, every vehicle that's been sold in the US since model year 2013, almost without exception, has complied with this regulation. There are some exceptions, there are some limitations, but generally speaking, essentially the entire road fleet at this point has gone the route of having 5 seconds of pre-crash data, either at 1 second or half second or 0.1 second intervals. And we're seeing many, many more cases where it's gone to that 10 hertz or 10 samples per second frequency of data. And the data elements are, older vehicles have fewer data elements, newer vehicles have more data elements. And those data elements can include a whole lot of very useful parameters that we can make use of. Most obvious ones, of course, being speed, but there are also elements like accelerator pedal application, brake pedal application, steering wheel angle, which would indicate what the driver was doing. Then there are data elements that will tell us what the vehicle was doing. So we might see engine RPMs, we might see yaw rate that tells us how much the vehicle is turning from about a vertical axis. We might see longitudinal or lateral acceleration values. We'll see representations of the collision severity itself, both longitudinal and lateral accelerations generated during the collision phase, which can be very helpful from an analysis perspective. It allows us to, for example, determine whether the speeds that we're determining or that are being reported are in fact accurate. And there are a whole bunch of reasons why any number of these data elements can be misleading or inaccurate. Most obvious, come back to, is skid marks. A vehicle that's skidding, if it actually does lock up the wheels, wheel speed is 0. The vehicle's still moving. So you may well have a sensor in the vehicle that is telling the general vehicle system that the speed is low or 0, when in fact the speed is non-zero. And that's most obvious when you're talking about skid marks, but it's also the case even with modern vehicles that do ABS or traction control, because of the way that those systems mediate or moderate braking so as to retain steering ability. So the system will try to ride the line, if you will, at the threshold of locking the wheel up. But then you get what we call incipient wheel lockup. So there may be a small fraction of wheel slip. It's not full skid, but there is an element of slip. So the speed at which the wheel is turning is slower than the true speed over the ground. So you need to be able to reconcile those. And oftentimes, or many times, the severity of the collision as recorded by the accelerometers will allow you to verify, or in some cases disprove or invalidate, the speed being reported by other vehicular systems. So there are a lot of interrelated and I guess corroborative or contributory elements that we can download from essentially all modern vehicles at this point. The question becomes one of, can we get that data? Did the system actually record data? And so on. Oftentimes, in the more minor collisions, getting back to cap regime type collisions, you may not have an event. If the collision is below a certain level of severity, there may not be any data recorded. So there may simply be nothing to recover. If the vehicle has gone back into service and has had other events, they may be overwritten, that there is limited recording space in these devices. Most of them can record multiple events. Most of them can record at least 2 events. but not all. And in some cases, the way that they record events is kind of a little counterintuitive. So you might have for example, a Toyota system that is theoretically capable of recording 6 events, but it's 2 front rear events, 2 lateral events, and 2 rollover events. And a corner impact, for example, could be a front rear, a lateral, and a rollover all simultaneously. So one impact could be 3 events. So you can have a case in which a vehicle that was not proactively downloaded has gone back into service and ultimately has been subjected to enough other incidents that you can no longer recover data. But in a lot of cases, most people don't have a whole lot of collisions in the life of the vehicle, hopefully. So the data may well be still present in the vehicle, even in a vehicle that's gone back into service, even for an extended period of time. The data doesn't, well, there are exceptions. I was going to say the data doesn't actively erase, but in a lot of cases, that's true. But for certain GM products pre-2013 model year, there are circumstances under which that data will actively erase. But it's only GM products, and it's only pre-2013, which is becoming less and less of an issue right now. So a vehicle that has gone back into service, if it is in that regime of older GM products, you might find that after, depending on usage, 4 months, 6 months, the data might be lost. Average usage for typical drivers is about 2 to 6 ignition cycles per day, and those GM products might erase after 250 ignition cycles or 500 ignition cycles, depending on the vehicle. So yeah, we can lose data, absolutely, for a vehicle that goes back into service for any number of reasons. But again, the more proactive we get, the more likely we are to gather that evidence and be able to make effective use of it in a lot of ways.
Yeah, and for us lawyers, where I would say there's a lot of insurance companies that for whatever reason they've requested that a data don't download be done. And it's great when it shows up on the file. I mean, you're telling me about these Bosch reports. When I look at them, yeah, it looks like it's in a different language, but obviously there's a wealth of information in there that could be explained to us. But even if our clients haven't obtained that information early on, whether the vehicle's been, yeah, continuously used, or actually was just ended up in a junkyard somewhere, it is possible to retrieve that data even years after the fact, except for those old GM vehicles.
Absolutely. I've had cases where literally 2-3 years after the fact, a vehicle that was disposed of is literally still sitting in a junkyard, rusting quietly. And particularly in cases where airbags have deployed, that airbag control module has no legitimate value to people who take parts from vehicles. Generally speaking, an airbag control module that's commanded an airbag deployment cannot be reused. It's going to set the airbag warning light on the dash, and it's going to tell you, look, you can't rely upon this thing. Manufacturers generally are on record as saying that once an airbag control module commands an airbag deployment, the fact that current has flowed through the circuit board calls into question the reliability of the circuit board. It can no longer be relied upon. And so the proper technique is to replace the airbag control module when you replace airbags in a vehicle that's been repaired and back into service. If a vehicle is sitting in the junkyard and it's had airbag deployment, nobody wants that airbag control module, because if you're repairing a vehicle that's had airbag deployment, you put the airbag control module from another vehicle that's had an airbag deployment, you're no further ahead. You're still going to get that idiot light on the dash telling you, nope, airbags aren't going to work. So right. I've literally walked up to a vehicle that's been sitting in a junkyard for 2 years, and it's been stripped to the bare bones, and the airbag control module is still bolted to the floor and right. there for the taking. We had one case where a vehicle was disposed of, and by the time we located it, we were told, well, it's sitting in Montreal. Yeah. Go to the airport, fly to Montreal, do the download, fly back same day. The total cost for the file wasn't radically different than our normal files, other than the $200 for the airfare to fly to Montreal and back.
Oh, and your trip, you probably spent some time in old Montreal, checked out the Notre Dame, all that.
Nope, same day, in and out, same day.
Business,
Airport,
business.
junkyard, airport, home.
I was going to say, I mean, and again, kind of bringing back to practical realities for lawyers, this is why, and maybe more so for young lawyers that may not know these things, is that why it's important to be, when there's an active, whether it's a liability issue or a force of impact issue, they need to ask questions about whether the person still has the vehicle. If they don't have it, did they sell it? Was it written off? If it was written off, where did it end up? Because you just don't know. Yeah, this information may still be findable and gatherable. And then the other thing we talked about was if they do still have the vehicle and they've been using it, is getting information from them about how often they drive it, um, and things like that, so that when you guys get the download or look at it, it provides a little bit of context if there are more events, about the number of ignition cycles and these types of things to figure out what the proper event is, right?
Precisely. And you raise a good point. You can, if there are other events that have been stored, that's really one of the risks of a vehicle that's gone back into service, is perhaps not necessarily the overwriting of data, but the introduction of new data. And then we're left wondering, well, which of these events is the one that we care about? Generally speaking, airbag control modules neither know nor care what the time or date is, and they don't have a time date stamp associated with the data. That's changing as well. Again, newer modules are more sophisticated. You're getting more and more information. Some current modules are doing time date stamps. Some current modules are even doing GPS locational pin for the data. So it becomes obviously much easier to determine whether the download is related to our subject incident or not. But generally speaking, that's not the case. I would say 99% plus of the downloads we do have neither time date stamps nor geolocation data associated with them. And in cases where you're talking about non-deployment events, where an airbag or a pyrotechnic device has not been commanded to deploy by the system, it can sometimes be tricky to discern which event is relevant to our circumstance. So yeah, driver behavior, driver history, vehicle frequency is relevant when it comes to trying to determine, is this event the one that we're talking about?
And as you mentioned with the EDR, I mean, yeah, if an event is recorded, they've got sort of I think you said it was a 5-second window leading up to the collision that they'll record. But I think lesser known types of data, which I had no idea until you mentioned to me, was this idea, the infotainment and stereo systems and things like that, or even cell phones that may actually be holding this amazing data that you guys can use, that actually covers a much larger time frame. Can you tell us a bit more about that?
Sure. So by design, airbag control modules are intended to be detecting and recording collision-related events. And as a result, the data tends to be managed in a certain fashion. And events tend to be categorized, they can be locked, they can be stored, they can be protected. Other types of devices can store information that may be peripherally related to the collision, not necessarily as collision events, but just normal usage, or in some cases, some of the safety related things that happened surrounding the collision. So a little more directly collision related might be something like Toyota's vehicle control history data that is associated with what's called the TSS, the Toyota Safety System. Depending on your make model, you might have any number of versions of TSS that can be implemented. And again, more recent tend to be more sophisticated, tend to have more data elements. I'm sure you've seen vehicles with little cameras in the windshield, the little triangular cutout where the camera is looking forward. A lot of Toyota systems will use that camera for things like pedestrian detection or lane keeping assist or whatever. They don't necessarily pertain to the collision directly, although they can, because brake assist is also one of the functions that can be implemented in TSS. Collision avoidance and collision moderation or mediation are factors in TSS. But it's not the impact itself necessarily that generates the event. It's the driver braking aggressively or swerving or cross-direction traffic being detected or something like that. All of those various parameters can result in TSS detecting and attempting to intervene in some cases with the vehicle actions, and data can be stored. That data can include elements like vehicle speed, engine RPMs, all the stuff that we care about, and it can have a much longer shelf life, and it can involve a much longer time period. TSS can involve multiple seconds or minutes of data, and it can be stored for a much longer period of time. There's much more memory. So Toyota vehicles in particular are one that we really like to explore the vehicle control history data from, and that's a little more directly collision related. Moving a little bit further away from that, you might have what we call the infotainment systems, and that's a whole area of interest in a lot of ways. A lot of insurers, for example, care about this stuff because it can be used for fraud detection and response. Police agencies care about this stuff because it can be used to determine vehicle actions during criminal matters. I've assisted with criminal prosecutions. I've assisted with missing persons cases and murder and so on and so forth, because the airbag control module isn't helpful in these cases because of the absence of geolocational stuff, but the infotainment system has, because of other reasons, because for reasons of the driver experience, might store where you've been because it wants to know where it wants to be able to assist you if you want to navigate back to a region or an area you've been previously. So in a lot of cases, your navigation system will remember where you've been just in case you decide, oh, I want to go back to a previous destination. So you may well have a system that stores an extended period of geolocation, time date stamped. Well, if you have a high frequency of positions and known times associated with those positions, you can calculate speed, for example. So these parameters are not directly intended to be used for the purposes of collision investigation or litigation, for that matter. But to be blunt about it, they're probably intended at some point. The manufacturer is hoping to use them for advertising, data mining, which is of course a whole other issue when it comes to privacy and everything else. But that's probably the underlying reason for a lot of this stuff. But it's there, and it's something that we can access.
Does the navigation system or the stereo or whatever, does it have to actually be turned on for it to record or store the data, or would it maybe be there anyway?
I'll give you my absolute favorite answer. It depends.
Okay.
Some vehicles, yes, it has to be actively engaged. Other systems, it does not. In some cases, you may well have a vehicle that has no user-facing navigation at all, but it's still in the background storing GPS data.
Okay.
Again, for a variety of purposes. Some systems, for example, older GM products with OnStar, let's say OnStar 8 or OnStar 7, in some cases that may need to have an active OnStar subscription and be actively engaged in navigation in order to have that breadcrumb trail of vehicle activity.
Mm-hmm.
Newer systems, same manufacturer, you don't need that subscription to be active, and you don't need to be actively engaged in navigation. I had one case involving a GM product, let's just say, in which the vehicle was, after the crash, stored in a small town wrecking yard, and parties unknown stole the airbag control module out of this wrecked vehicle. Interesting question as to why anyone would bother to steal the airbag control module out of a vehicle with deployed airbags. One might be able to speculate as to the identity of who did steal that airbag control module and their reasons for doing so, but I would never dream of articulating those speculations. But our hero, whoever that might have been, failed to appreciate that there were other modules in the vehicle that had useful information. We ended up interrogating I believe in that case it was the OnStar module and the HMI module, the human-machine interface, dystopian as that might sound, that's what they call the module. And we were able to establish, not only did we locate the collision event itself and with geolocation data, location, time, speed, and so on, we had days of data coming from those systems that told us what this guy was doing in 5 minutes before, 10 minutes before, 5 hours before the collision, what he was doing out on the highway and not in town, and how he was driving this vehicle in the days and hours leading up to the collision. To be honest, we might not have found that if it hadn't been necessary for us to go digging, because presumably we would have downloaded the airbag control module and been interested in the circumstances of the collision itself and gotten 5 seconds of data, which would have told us, yeah, he was doing, I forget, whatever it might have been, 80 in a 50 zone or something like that.
Yeah.
We probably wouldn't have detected the fact that he was doing 200 in an 80 zone 5 minutes before that. So it's interesting. There's lots of data out there, and it can be accessible by different means, and different systems are generating different data. But there are lots of data sources that can sometimes be put to surprising use, and not necessarily in-vehicle data sources.
Yeah,
we do pretty much the entirety of what we do is collisions, if you will. Some sort of wheeled vehicle, some sort of wheeled conveyance collides with something. So that might be car versus pedestrian, but it might also be bicycles. It might be bicycle versus pedestrian, or bicycle versus bicycle. And more and more frequently, we're seeing those kinds of data sources. Did you have a head unit on your bicycle, that trip computer on your bicycle? That might have geolocation or speed history that is accessible and usable. Are you wearing one of these things that might very well have been logging your ride? Or are you using the Strava app on your phone because you like to keep track of your pace for your daily routine ride? So those kinds of technology are out there, and again, they aren't by design generating data that's intended to be used in the context of crash investigation, but in a lot of cases they certainly can be used if one's careful with sourcing the data and keeping it honest by comparing it to other data sources and such physical evidence as available and so on. But they're certainly out there and certainly accessible.
Yeah, and again, I have to come back to, it's just, and I'm thinking about this more now, is just the types of things that lawyers need to be thinking about when they're doing discovery. I wouldn't have thought about, were you wearing, I mean, we ask people if they had their cell phone with them, sort of kind of thinking, well, were you using it at the time and were you distracted? But not necessarily thinking, well, maybe we can get the GPS information out of that. Or yeah, were you wearing an Apple Watch? I mean, there's all kinds of interesting things that we just need to be a little bit more mindful of. And now we're getting into, advances and changes in technology, and we only have so much time left. And I really wanted to ask you about what you think about, the introduction of, self-driving vehicles, and what you think that means for accident reconstruction moving forward. Like, how is that going to change the landscape of things?
Well, as Yogi Berra said, prediction is hard, especially about the future. It's going to be a game changer. I don't think there's much doubt in that regard. Certainly, these autonomous systems. Well, to some degree, we already have a degree of autonomy, and people don't think about it in those terms, perhaps. But when you're looking at traction control, for example, the intent of a traction control equipped vehicle, and by the way, traction control is now mandatory in the US market, again, something we're inheriting. The intent of the traction control system is to assist a driver in maintaining control of the vehicle. So you need to have a variety of sensors in the vehicle that allow that system to determine both what the driver is asking for and what the vehicle is actually doing, and give it the ability to moderate, mediate, intervene in order to accomplish that desired outcome. So you will be looking at things like steering wheel angle and brake application and accelerator pedal application as an indicator of what the driver is attempting to accomplish. But then you'll also be sensing things like the vehicle yaw rate and individual wheel speeds to determine if the given steering wheel angle for a particular speed matches with the yaw rate of the vehicle, which yaw being kind of an automotive slash aircraft term for rotation about the vertical axis. So if you're looking down on the vehicle, turning left or right is yaw. That yaw rate, if you're negotiating a given turn, let's say a given radius turn on the highway, you may introduce a certain degree of steering wheel angle. The vehicle is going to negotiate that turn with a certain amount of lateral acceleration, a certain amount of yaw, and the individual wheels are going to have different speeds. Wheels on the outside of the vehicle are going to take a longer track around the turn than wheels on the inside of the vehicle, which will take a shorter track. So the wheel speeds will be different. Traction control system is going to look at those inputs and go, I know for a given steering wheel angle at a given speed what I should be seeing for yaw rate and wheel speeds. If I don't see that, that's indicative of some sort of loss of control. And it may be able to discern this wheel is slipping. I can tell this wheel is slipping because its speed has gone up and it's out of sync with the others. So what I'm going to do is I'm going to apply individual braking to that particular wheel and bring the vehicle back into line. Well, that type of activity is something that a driver cannot do. We as car drivers cannot choose to brake just my right rear tire. We press the brake pedal, we're going to do a more bulk application of braking. So there's already, to some extent, a degree of autonomy in some of these systems. The computer is interpreting your desire and mediating the vehicle control systems to attempt to accomplish that. As a result, that's one of the reasons why we're seeing all of this more sophisticated data in the airbag control modules. It is necessitated, it has been necessitated by the requirements of these types of systems. So you have more sensors in the vehicle communicating to more computers in the vehicle over this shared network that the airbag control module listens in on and records data from. I think the more autonomy we see, the more data elements are going to be generated. I've seen some of the data streams that come from, for example, Tesla's self-driving features, where it's categorizing vehicular and pedestrian traffic. And the amounts of data that are being generated are huge. It's mapping in space all of these parameters that it sees, that is detecting by radar, that is detecting by visual means through cameras, detecting by sonar. There are all kinds of sensors that provide data that are well beyond our capabilities as humans, and they're recording all of it. So there's a lot of data elements that we are going to see more and more of as vehicles move closer and closer to the various levels of autonomy. Autonomy isn't binary; it's not on or off, and so many vehicles have certain degrees of autonomy even now, like traction control, for example, like cross-direction traffic detection, brake assist, pre-impact brake charging, all the various safety devices that are being implemented by various manufacturers. NHTSA defines 5 different levels of autonomy, 1 through 5, and the higher you get, the more you get toward what we think about as being autonomous self-driving vehicles. There's nobody right now doing truly autonomous vehicles, with very limited exceptions. There are some pilot programs, I believe, taking place in a few jurisdictions around the world where truly autonomous activity is occurring, but it's under very limited circumstances on specific roads that are very limited access, very well understood, very accurately mapped out, and so on. But I think we are generally moving towards more and more autonomy. Until we get to the point of full autonomy, I think largely what that's going to mean is more and more data for us to work with, because there are more and more sensors. So we're getting a lot more information that we can use, both in terms of what the driver was asking for and what the vehicle ended up doing, which is, of course, useful in the context of a collision investigation, answering questions as to who did what when and who's responsible for the outcome that took place here.
Well, yeah.
When we get to full autonomy, everything changes.
Well, the developments are going to be pretty fascinating from a fault perspective, because, once it's fully autonomous, we're no longer talking about individual or the driver fault. We're talking about, manufacturer issues and stuff like that. I mean, there will still be fights and to be had. But yeah, the fault scheme changes a little bit for us, I'd say.
Very much so. There's been some suggestion. I've seen some literature that suggests that the idea of auto insurance may well disappear
Right.
because you're no longer talking about drivers being responsible for the actions of the vehicle. You're talking about manufacturers being responsible. I believe at least one, I think Volvo is on record as saying they're going to be responsible for what their vehicles do as they become autonomous. So we're going to be heading into an interesting regulatory period where, as you start implementing these vehicles on the road, is it going to be appropriate or necessary for drivers to have liability insurance anymore? Is it? Do you need to, as the occupant, not driver, but occupant of an autonomous vehicle, have insurance because it's not your actions anymore that govern what that vehicle is doing? So it's interesting times.
Yeah, well, and yeah, we could probably spend an entire podcast talking about that. But I do have one more important question for you, and without sounding too morbid here, equating something to, a last meal. If you were allowed to have one, I know you're a beer person like I am. So if you were told you could have one last beer, I don't want to say before, if you were on death row or something like that, just you were only allowed to have one more beer, what would your choice be?
That's a difficult question.
I don't know how to answer that question, so I don't know why I'd be cruel enough to put that to you, but just say the first thing that comes to mind.
Here we are. As you said, I'm a beer person, and I'm a ridiculous beer geek, and completely insufferable, in fact, and I recognize that. So asking me what my favorite is a very difficult question. It's fraught with difficulty because what style, under what circumstances, what are we doing? So are we talking a lawnmower beer, or are we talking a sit down in a
You're
in a,
right.
in a quiet
It's
pub?
very different. How about a post-podcast beer?
Post-podcast beer. Well, I've had arguably among the best beers in the world. But for different styles. But I think if you were to say to me, what is the most enjoyable beer experience? I think sitting in a little pub in Brussels, Au Bon Vieux Temps, I believe it was called, the good old days, having a West Vleteren 12 a few miles away from the abbey where it was brewed. And West Vleteren 12 is, in a lot of ways, generally regarded as the best beer in the world. That was a pretty special beer experience.
Now that you mentioned that, when I was in Belgium, there's the Duvel and the Chimay Blues and all these ones.
Yep.
If you're a beer person, that is absolutely the place to go. Here we drink our Stella Artois and think it's this fancy beer, and that's probably one of the worst beers in Belgium, right? So
that's a soccer hooligan beer.
Yeah, exactly. Well, we could go on and on about this forever, but we are pretty much out of time here, so I really appreciate you being here. You have so much knowledge on this topic, and it was really, really interesting hearing your insights, not only about, accident reconstruction now, but also where things are going. And it's been great having you here. Thanks again.
Oh, you're more than welcome. I'm happy to be here. I enjoyed it.
All right. Well, that's all the time we have for today. And we'll look forward to seeing chatting with our listeners on the next episode.
You've been tuning into the Lawyer Up with HMC podcast with your host, Kristen Hagg. You can find this show on all the major platforms, including YouTube, LinkedIn, Facebook, Apple Podcasts, Spotify, and on our website, hmclawyers.com. Thank you for your positive reviews, comments, questions, and for sharing this show with others.